Okay, this is our second video, and we're going to take a look at three inequalities. Each of these inequalities has a factor in it which proved difficult for some students in grade 8. So pay attention, and if you had difficulty with one or more of these situations, hopefully this will help. So our first inequality is 5 is less than 2x plus 1. Now the difficulty here that some people felt was that the x is on the right-hand side of the inequality sign, and this led to some difficulties with graphing. Okay, but first let's solve it. So as you know, the rules for solving inequalities are very similar to the ones we use for solving equations. So first I'm going to subtract 1 from each side to nullify the addition of 1 here, and I'm going to end up with 4 is less than 2x. Now once again, 2x is a multiplication question, 2 times x. So in order to make x stand alone, I need to use the same value, which is 2, with the opposite operation, which is divide. You cannot subtract the 2 away, you need to divide it away. Okay? And I do it to both sides. So I end up with 2 is less than x. Now, this is where we had some problems in the classwork. Okay? So we can go ahead and circle this. We know that x is not equal to 2, so it's going to be an open on 2, but which side do we draw the arrow? What some people did was they saw that this was a less than sign, and so they automatically drew the arrow to the less than side. But 2 is less than x. Okay, it doesn't say x is less than 2. If it were x is less than 2, we would draw it to the left. But the x is on the other side. So if 2 is less than x, then if we read this inequality backwards, we get an equal statement, the same statement. X is greater than 2. And we can actually flip this around and say x is greater than 2. Something I want you to be aware of here is that the inequality sign up here is open towards the x. When we flip the positions of the x and the 2, the open side of the inequality sign must still be towards the x, which means we flip it. So whether you're looking at it as x is greater than 2 or 2 is less than x, either way you're going to be graphing to this side. Some of you had a hard time with this because graphing to the right-hand side with a less than symbol did not make sense, but that's the correct way to graph it. Okay, so let's move on to the next one. Okay, so the difficulty in this one, negative 3x minus 1 is greater than 7, is the fact that there's a negative coefficient, a negative 3. So let's see how this plays out. So first I'm going to add 1 to each side, and that's going to give me negative 3x is greater than negative 6. Now here is where things get a bit tricky. I need the x to stand alone, so I'm going to divide by the coefficient, which is negative 3 on each side. Now whenever I divide or multiply by a negative in the solution of an inequality, I need to flip the sign. So I have x by itself, and now it's less than 2. X is less than 2. So I'm going to graph this. I'm going to graph it in blue here. So this one is open again, and less than is this way. Okay, don't forget to flip that sign when you're dealing with negatives. Okay, now we have a variable on each side of the inequality sign here, but we're just going to go through the steps of solving it just like an equation. So first I'm going to add 3. I'm going to add 3, there we go, to each side. These cancel out. I still have less than or equal to 4x, and on this side I have 2x minus 4. Okay, now I want my variable on one side and my whole number on another side, So it makes sense for me to deal with the negative 2x. I want to get rid of it entirely, so I'm going to subtract the whole thing. This is not the same as what we did over here. Over here, I divided by 2 because I wanted to be left with x on this side. This time around over here, I want to get rid of the whole thing. I don't want to be left with anything. I don't want to be left with a number. I don't want to be left with an x. I want it all to be gone, so I'm going to subtract it away. And I'm going to do the same thing over here. So 2x minus 4 minus 2x leaves me with negative 4 is less than or equal to 2x. Now I'm going to divide by 2, not subtract 2x. Why? Because I want to keep the single x. Over here, I didn't get to keep anything, and I didn't want to keep anything. I want it all gone. There's nothing here, and that's the way I like it. But with this one, over here, 2x divided by 2, I'll divide by 2 over here, I want it exactly that way because I'm going to end up with negative 2, and I'm going to have my x, and this is what I need for my solution. I want a statement of how x is related to, in this case, negative 2. Now, we have the variable on the right-hand side again. We know what that means. So let's take a look. We'll do this one in green. I'm going to go for negative 2, and I'm going to circle it in, color it in, because it's less than and equal to. Now, which way is my arrow going to go? Well, if I read it this way, it says negative 2 is less than or equal to x. If that's the case, then x must be greater than or equal to negative 2. And if I read my inequality backwards, I get exactly that. Or if I flip it, I get exactly that. So the arrow is going to go to this side. Okay, so those are 3 examples of some issues that came up in our solutions of multi-step inequalities, and hopefully I've touched on something that will help you as you prepare for the test.